Hi, folks. This is Carl from United Bugs. I'm trying something different today. I have no idea if you're actually going to see this. I'm going to record a bunch of stuff today, kind of like I was doing a live stream, which I've never done. If you see this, if you think it's interesting, let me know. I might end up working live stream into what I'm doing. If you are seeing this, just so you know, it's an edited version. I'm cutting out a bunch of ums and ahs and stuff. So me on a live stream is not going to be nearly as concise as me in a VOD. This is going to be pretty unscripted. I've got some notes in front of me. I've got some stuff here you'll see as I go. So it's not going to be as well thought out as what I usually do because I haven't gone through draft after draft after the draft of this. But we'll see how it looks, see how it turns out. So what I want to talk about today is AI in the security space. Some recent things that have happened, some research, some events. But more importantly, I'm going to talk about what I think that AI and the security space and the intersection at the moment thereof says about what it's going to be for us from a career standpoint going forward, at least for however long my crystal ball is accurate. I want to start with this particular report. Oh, I also want to warn you, unlike what you might think of my normal videos, at least what some people, the impression some people have of my normal videos, this is not a completely bashing AI video. The first part of it's kind of anti-AI. By the time I get to the end, there's actually some less down on AI stuff. So despite what the first few minutes might seem, this is not just going to be me beating on AI for the whole time. Okay, so I'm going to talk first about this Cybersecurity Risk of AI Generated Code report. It's from, actually, I'm not even going to try to read those because I'll probably butcher them. I'll put links down to these, of course, in the description as I always do. Believe it or not, the cover of this report and the color of the stuff on my channel just happened to be matched. I didn't actually do that on purpose. So here's where I want to start talking. There's a lot of stuff in the first part of this paper about adoption of AI in the coding space. I'm not particularly worried about how fast it's being adopted, that kind of stuff. We can talk about that kind of stuff later. If that's something that's interesting to you, let me know. What I want to talk about at the moment is this study that said that this is as of September of last year. People found a 26% increase in the number of completed tasks among developers that were using Copilot compared to developers that weren't. This kind of scares me because just because the task is completed doesn't mean it was done correctly. These are the kinds of statistics that show up in boardroom conversations when people are talking about reducing headcount and hiring for next year and budgeting for projects and that kind of thing. So that's a bummer when these kinds of statistics come out and they end up being the top line number that people talk about, and there's not a lot of nuance that goes along with that. So I want to talk a little bit through the greater implications of that. Today, we're talking about security. So I'm going to start with this, talking about this study from 2021, which is not that current, but I'll get to some studies in a sec that are more current. This one shows that, so 40% of these programs in this particular study were vulnerable to the top 25 most dangerous weaknesses, right? So this is not had a bug at all. 40% of them had a bug that was in the top 25 worst bugs that you could possibly make. By the way, these are not this common weakness enumerations list. This is not the most dangerous weaknesses that were discovered this year. This is the most dangerous weaknesses of all time. And this code is, this Copilot generated code has 40% of the time one of these 25 weaknesses in it, which is just terrifying, right? Next study, let me switch to a different color. So our next study is in 2022, and here we have 68% and 73% of the code samples from either Encoder or GitHub Copilot. I'm not sure what Encoder is, but it doesn't matter. Had vulnerabilities when checked manually, right? So now we're not talking about the 40% that had the worst, one of the top 25 worst bugs. We're talking about 73% of the code has some kind of bug in it at all once it's looked at manually, right? 2023, another study, only 5 out of 21 of the sample set for that particular study were secure. Back to yellow. Here's another one from 2024. 32.8% of Python and 24.5% of JavaScript snippets contained 38 different security bugs, 8 of which belong to the top 25, right? So here's this is a study of 450 different code generations, right? And a third of Python and a quarter of JavaScript have bad code in it. I'm expecting if you follow my channel, you're not necessarily going to be surprised about this, and you're not going to expect that I'm going to be surprised about this. However, this is however bad these are, this is way, way worse than you think. So let me explain why. So here is the results of a survey that says that people believe, for some reason, that AI code is more secure than human code. The word is not getting out to folks that AI code is not great, right? And there's this bias that people have that AI code is going to be better and more secure than the code that a human writes, which obviously is not the case, right? Even without knowing, the 40% of code generated that had the top 25 weaknesses in it, even without that, we know it's not going to be more secure over the long term. The problem is that 76% of people believe it is more secure, which means they're not going to do as good a job of looking at stuff. They're not going to do as good a job of hiring people who know what to look for and know how to audit code and know how to fuzz code and to try to find errors in it. And that's setting us up for even more bugs on the internet that's already full of bugs. Now, I've got some anecdotal evidence. So recently I was on a podcast, and short version is I was explaining to Ed, the host of the Better Offline podcast, that the idea of a human being able to look at code and through a code review process or just diffing code or that kind of stuff, can look at code and know that the code is secure. And as an example of that, I brought up this bug called heartbleed. The bug's not important right now. The main thing that's important about it is it was a really nasty bug, had really bad implications. It was a check that didn't happen, so it was a code omission. And it had been out for 2 years or so before the bug was actually found. And I was explaining this to him, and then he used it when he was writing up some stuff as an example. And then some person on Blue Sky basically jumped in and said that comparing LLM code to heartbleed, this OpenSSL bug, is not a good comparison. Somebody asked him why. And he said that LLMs would neither cause nor prevent a bug as subtle as undetected as heartbleed was. So what he's saying, if I can rephrase this, is that it's not possible for LLMs to omit a line of code the way that a human professional security programmer does, which is just completely ridiculous. And the opposite is true. But this is a conversation from last week. And this is someone who is in the industry. This should not be a question, right? But the idea that, the LLMs have to be secure, right? So then the conversation continues. And someone else comes in and says, basically, I see students frequently that have SQL bugs, security bugs in their SQL code. And then our LLM defender says, most SQL clients have a pattern that handles sanitizing inputs. Now, the idea that if you correctly sanitize inputs, that your SQL code won't have injection problems is nonsense. I can give you years worth of SQL injection bugs. Literally, year after year after year, there are more and more SQL injection bugs, even for people that use the right libraries and supposedly sanitize their inputs correctly. And we'll talk later in this video about some input sanitizing code that didn't end up working right, although not in a SQL context. So then this person that has seen his students have SQL problems comes back and says, I have seen exactly that. The LLM defender says, I just tested this, and every one of them does the right thing, right? The idea that you can do one query, get an answer, and believe that because you got the right answer, that an entire classroom full of students will also always get the right answer, and whoever it is that's telling you the classroom full of students can't get the right answer or hasn't gotten the right answer, it must be wrong. And then this really summed it up for me. It's always hilarious when one of these guys says, oh, an LLM would never do the thing. And then someone inevitably rolls up and says, I'm an expert who has personal experience that they've done exactly that. And then they just cannot accept it. This is life in the LLM space, right? The AI quality derangement syndrome. I need to come up with a name for that. There really ought to be a good way to do that. AI derangement syndrome? That's not good enough. Bot derangement syndrome? Anyway, so we've got this derangement syndrome problem where many humans are just incapable of treating AI skeptically, in trying to find out what the actual evidence says. And there are a lot of people that are just hype derangement syndrome. That's probably a good one. I like hype derangement syndrome. So we've got this problem with hype derangement syndrome, AI hype derangement syndrome. We've got this problem with AI hype derangement syndrome. So I've seen this a lot, right? Just like with the 76% of people that responded that AI code they believe is more secure than human code, this person that ought to know better just can't accept the fact that even if he hasn't, there are lots and lots of people that get bad code from AI. It's a fairly high percentage. And these people just have AI hype derangement syndrome. And they're just convinced not only that the AI is going to be exponentially better in just a couple of years, but also that it's actually functioning now in a way that's far better than what people are actually seeing on the ground because they don't want to pay attention. So I'm going to talk about another specific example. So let me start by talking about this particular video is fantastic. This is a channel called Low Level TV. He is a security researcher. He's amazing. I am not going to go into a lot of great detail on this particular bug because his explainer video, which looks like this that I'll link below, is a much better explanation of the low level of what's going on. So let me just talk to you about the higher level of what happened and what was to happen. So there's this library called Langflow AI, right? So this is a library that does, it's like a low code thing where you tell it what you want to do, and then it writes code for you, as I understand it. And it's a library, it's a Python library, and it's used by a bunch of different people to write their own servers. And it had a remote code execution vulnerability in it, which is terrifying. And it was fixed in version 1.3. We'll talk about that in a little bit. You give code to this thing, and it's a low code thing. High level, what happened is there's a validate code routine that this thing can run. And the validate code routine actually correctly attempts to sanitize its inputs, right? So it uses the AST module to look at the function definitions and to import the thing. It does import module. It's doing all of the right sanitation kinds of things that you would expect it to do, right? It is not running the code explicitly. All it's doing is looking at the functions and making decisions based on the function. However, what happens is it turns out that that library that they're using to sanitize their inputs doesn't recognize the fact that Python decorators can be executable. And the Python decorators are actually executed as part of the function definition. So that creates this idea where if you submit code with sufficiently malicious code decorators, you can get arbitrary code execution on any server that's running this library before the version that they patched. Problem is, if we look at this bug report, right, what we find is that this wasn't really reported as a remote code execution bug. This was reported as an unauthorized remote code execution bug. So what they did is they decided that the real problem was not that they had remote code execution, but that they didn't have authentication on top of the remote code execution. And if you look at the fix, you'll find that what they actually did was they just added the current user to that function that did the bad thing. So now, in order to be able to hack a server and send remote code execution to it, you have to do more than send a malformed Python decorator. You have to send a malformed Python code director and have an authentication header. That's not that big a barrier. Right? Now all you have to do is figure out brute force, bad accounts, some person who's got an account on the machine, get a hold of their credentials, and now you can do remote code execution again. So if you watch my video on dealing with cloud secrets and on the various different ways that a security engineer should pile safety feature after safety feature after safety feature on top of code, so that in the event that one of those or two of those have a mistake in it, that the attacker is still going to have something else that they need to do in order to be able to own your machine. This, in my world, in my opinion, this is not good enough at all. This is awful, right? You don't just go, oh well, now because the user has to be logged in, then it doesn't matter that they can run arbitrary code on our system. And understand, this is not a group of people who are writing this code who are trying to protect their own system. This is a module that gets included in other people's Python code that gets deployed out on the internet. And these people are deploying this code out on the internet that has a remote execution bug. And they were told that it's fine just because the user has to be logged in before they can run arbitrary code on your server. It's not good enough. It's just not good enough. All right, let's move on to our next topic for the day. So this is another way that AI is making us less safe. So this made the news, so you might have heard about this. But the administrators that manage the curl library. Now, the curl library, I don't know if you've ever seen the command line curl, which is a tool that you can use to go fetch files from servers and that kind of thing. Underneath the command line version of curl is a thing called libcurl. And libcurl is in a lot more software than you probably think. I've been part of a lot of different projects that were written in other languages where the library that we were using down under the covers ended up falling back to libcurl because there's so much work that's been done in that library year after year after year for all of these weird esoteric parts of the HTTP protocol or whatever that are really, really hard to implement correctly. A lot of times it's just easier to use that library than it is to try to write all of that code yourself, even writing all that code in another language. I've seen libraries in non-C languages that ended up resorting to libcurl down at the bottom. When you call go fetch a web page or go fetch an API call from your language, and it turns out that when it gets down to the bottom of the stack, it's actually calling libcurl to actually do that and then bring it back up to you. And you have no idea it's actually doing libcurl stuff under the covers. Libcurl is drastically important that we keep safe. And bugs in libcurl can cause all kinds of nasty problems. And so it's very important that we find the bugs in libcurl and that we get them all fixed. So here's your bug report that came in for HTTP 3. So HTTP 3 is a relatively new protocol. It's not that commonly used yet. The code that does it is still relatively new. So it's not unreasonable that there could be a bug in HTTP 3 code. And unfortunately, what can happen is when you add new code to implement a new feature, this isn't just true for curl, it's true for anything. A lot of times when you add new code to implement a new feature, someone can make malicious use of the features in the new code to be able to cause bugs even in the situation where the new code shouldn't be relevant. Okay, there's this new negotiation option. If I trick the code into going into that negotiation option, then I can find a bug because that code isn't nearly as well maintained because it hasn't been around for very long. So, if there's actually a bug in HTTP 3, it doesn't affect just servers that are running HTTP 3 and people that are fetching servers from HTTP 3. It potentially could be affecting lots of people that aren't running HTTP 3, but a malicious actor managed to get the right headers or whatever to cause the HTTP 3 code to get executed in an insecure way when it wasn't supposed to be there in the first place. So if you look at this bug, this is very useful, right? So he's got this proof of concept code. I presume that's a he. Actually it's an it. So we've got this malicious server that can end up causing problem. We've got a crash analysis. We've got our expected output. We've got our core up inspection. We've got all kinds of really useful appearing information here. Now we get down to where the curl staff people actually start getting involved. And they start by saying, hey, patch file you gave us doesn't apply. What the hell, right? And then our evil bug reporter, I'm not calling him evil. That's what he picked as his username. Says, oh, no, their patch failed to apply because the code base was updated. We fixed the patch. So then some more happens. And then we figure out, oh, there is no function called the thing you're trying to patch. This is AI Slop. And then the user comes in and says, oh, yeah, well, never mind. So this thing has like 4 or 5 pages worth of bug descriptions and answers and, oh yeah, that patch didn't apply because of such and such. Here, let me fix it for you, that kind of thing, right? And it's all 100% complete an AI hallucination. And it's so irritating that even with this kind of crap happening, we still have people like that moron over at Blue Sky who's like, oh, no, LLM can't have that kind of problem. However, despite this problem with curl, GitHub is currently in the process of allowing random people to just use GitHub Copilot to auto-spam bug issues against any public repository. And that's going to do an insane amount of damage to the ecosystem. All right, so let me talk about another new paper that's come out recently. I don't know if you've seen anything about this one, but there's been a lot of discourse about it lately. So I hate this paper, or this article, but I have to admit there is some valid stuff in here, right? AI is not a fad. I understand there are people that have this belief that AI is a fad. AI is not a fad. It's not going away. We have to deal with it. We have to make their best of it, but it's just not going to happen that we all go back to normal. We're never going back to what life was like before this. This is all progress on LLMs could halt today, and LLMs would remain the second most important thing to happen over his career. Now, I'm not sure. I want to say, yeah, so he's from the mid-1990s, so he's like 6 years younger than I am. I don't know that I'd go so far as to say this is the second most important thing, because, I mean, there's a lot of stuff that's really changed the world that a lot of people don't understand. So, like, one of the biggest changes that nobody really thinks about, but one of the biggest changes that changed the entire ecosystem was Amazon Web Services, and the idea of a cloud, right? So people talk about, the mobile, the iPhone and mobile devices changing the world, and they did. And people talk about the internet changing the world, and yes, that happened too. But like the existence of a set of virtual servers that you can go and just post your code to and not have to have your hardware anymore, that's made more of a difference, I think, than I think AI is likely to in the next few years. I might end up eating those words. Certainly, it's made a much bigger difference than what LLM's doing now. And here he's saying, LLMs could halt today. If all progress on LLMs stopped today, I don't think that the impact of that would be nearly as big as the impact of server virtualization and virtual servers and the idea of putting your code on a cloud. That made far bigger difference, as far as I'm concerned, than LLMs have made yet. LLMs aren't done, but I can think of several things I think are more impactful than what LLMs have been up to now. So some of this sounds familiar. I have done a lot of C code. I have not done a lot of shrink wrap. I've done lots of Ruby. I've done some Python. I really hate Python. I've always hated Python. I've got a video on hating Python. I have done some kernel work. Yeah, that was fun. I hacked a firewall into a kernel once. I did some kernel hacking on a network boot kernel to allow me to be able to remote boot a server over a T1 or over a VPN, which was crazy because it shouldn't have happened that way. But anyway, so I've never shipped kernel stuff, but I've definitely had kernel hacks inside products that I've services that I've worked on. Done a whole lot of server-side C. Go is pretty recent for me. Haven't done a lot of Rust. I've done other languages. I've done Objective-C. I've done Kotlin. I've done Swift. Anyway, next thing is go back to Pink. So if you were trying and failing to use an LLM 6 months ago, you're not looking at what people are currently looking at from LLMs. Sure. The idea of, we use agents, it's different. The new reasoning models make fewer stupid mistakes, but agents are not the panacea that people are making them out to be. There's some amount of use in that, but in my opinion, that doesn't make for the idea that there are agents and the idea that the agents can do a lot of things that, O3 can't on its own or whatever, right? Does not invalidate in any way the fact that O3 doesn't write good code, right? It doesn't write secure code. None of these write secure code. The fact that it can write more of this insecure code is not necessarily good. He's got this argument here about the difference between, tedious code and fun code and important code. And he's right that it is certainly the case that LLMs can generate a lot of boilerplate for you. I'm not that excited about that because I've spent a lot of time learning how to use various editors and how to basically construct my own macros so that I can type a thing once and then I can have the macro spit that out the next time I want it, and I don't have to write the same boilerplate over and over and over again. It's cool that the LLM can do that without having you have to resort to macros, but it's not. If you know how to use your tools, it's not that big a deal. It's convenient, but it really isn't that big a deal, right? This is scary. An LLM can be used to figure out all of your dependencies. I don't know if you've seen any of the reporting, but LLMs tend to hallucinate dependencies, and there are a lot of people that are creating malicious repos that are sitting on URLs that are the kinds of URLs that get hallucinating. So the idea that, we're going to just let the LLM figure out all the dependencies, I don't think it's a good idea, and it hasn't been my experience that works pretty well. Maybe if you're just doing Python and JavaScript, but neither of those are languages that I like to spend much time in if I have a choice. So he's got a point here, right? You are always responsible for what you merge, and the idea that you don't have any idea what the code is kind of stupid. Now, the problem is that, one, you will not think through the code that an AI generated as thoroughly as you would if you were going to write it yourself. And it's not unusual in the act of writing code for me and other people that I know to realize that our initial stab at how we should do this has a bug that will end up biting us later. And in the process of thinking through and writing what this thing is supposed to do, it's like, oh yeah, that wouldn't be good. I need to do this a different way. And you're unlikely to reach that kind of epiphany if all you're doing is trying to sanity check and rubber stamp the code that the AI generated for you. I stand by my statement, and I stand by my belief, and I stand by the research that I've talked about on the channel before, that Copilot specifically and LLMs in general are lowering the bar on good code. Now, as he says later in this piece, it's possible that AIs are also raising the bar on bad code. I don't know that that's the worst thing. And it's certainly true that I have gotten to the point where there are certainly situations under which I would trust O3 to write code or Claude to write code more than I would trust some of the junior fresh out of school developers that I've worked with, although hopefully they're better now than the last time I worked with them. But so this is garbage, right? If hallucination matters to you, your programming languages let you down. That's just not true, right? This is just garbage. I've got a video I'm working on. This whole, the agents compile and run tests. So first off, lint. If you think that lint is sufficient, you're wrong, right? Lint makes your code look cute. It makes it easier to read theoretically. It doesn't make it more secure. Right. The idea that the LLM runs tests is good. Problem is the test code that LLMs write generally is worse than the normal code that LLMs write. At least in my experience, I've got a whole video I'm working on for that. We'll talk about that when I get there. The idea that the LLM will invent a new function that's as bad as you're going to get for hallucination is garbage. Right. LLMs can hallucinate an algorithm. They can hallucinate the idea that a particular implementation will work better than something that obviously is better. I've done some work before with trying to get LLMs to do fast, well-understood algorithms for detecting and sieving prime numbers, and find that LLMs have a really, really hard time getting past the fact that there are so many tutorials out there about the really, really slow ways of finding prime numbers. That it's often really hard to get them to just use the algorithm, even when you tell them that. I've got a couple of videos on that. Although, granted, it's been a while. Maybe they're a little better now. That's on the pile of stuff to revisit. The idea that the agents say, I'm going to start working, you go do something else, and then come back. It's good and bad. This is treating it like it's all good, and it's not. The code it's going to generate is not going to be as good as what you're going to generate, and it's not going to be secure. Now, the thing, though, is it's true that the LLMs are much cheaper than a person. Much, much, much cheaper than a person. And you can have 50 times as much code generated by spending money on a bunch of different cursor implementations than you can by hiring somebody's fresh out of school. That's not necessarily a good thing, because a lot of that code is going to have issues. But as a cost function, right, it's indisputable that you're going to get more code for a lot less money than trying to hire junior programmers. And that's bad for junior programmers. Hopefully, we will get to the point where people start understanding the implications of all of this bad code that's being produced and all this insecure code that's being produced. But, that's kind of problematic. The thing is, I've seen some junior developers make really, really bad code decisions and generate really, really insecure, crappy code. So I'm not going to sit here and tell you that comparing Cursor to a junior developer is not a good comparison, because it is. But I'm afraid it's just going to take some really nasty bugs before people actually realize how much of a mess we've made, and we're going to have to figure it out. Okay. It's bad at Rust. So this is one that I've kind of taken some hit for, and I've talked when I've done some of my demos. I've found that it does a lot better in Python than it does in Rust or Go or Zig or something like that. So there are two issues here, right? One of the issues is how well can an AI reproduce code? How fast can it regurgitate code? How much can it be useful to you when it comes to trying to get your work done, right? The other one is how good an actual programmer is this? How good is this thing? How likely is this thing to actually be able to do as well as a programmer, to replace a programmer, that kind of thing, right? The second one of those is a lot more useful to think about when you're thinking about the future of AI, right? I've got some more. I've got another video that's going to be coming up that I'm working on writing on, that's talking about the predictions that people are making about AI and the way that AI is supposed to become super intelligent, all this kind of crap. That whole theory is premised on the idea that you're going to get AI writing the next AI. I don't know if you've read like Hitchhiker's Guide to the Galaxy, but basically, they created this computer that then turned around and designed the next smartest computer, and so on and so forth. And so understanding not how well an AI can reproduce something that it's seen before in a language that's got a lot of examples about, but how well a language can think about something that's new to it there are two very different answers. And the one about it thinking about something that's new to it is the thing that will tell us if the AI is going to be likely to be able to increase its own intelligence, or at least if it can't think productively about something that's relatively new to it, then it's got no chance of being able to increase its own intelligence. As long as it's not hitting this bar, then that tells me a lot about what I think the future of it's going to be, which is separate and distinct from down here. How well can this thing help me get my work done on a day-to-day basis because my work is boring and I've got a lot of boilerplate, right? So he has had, he says he works mainly in Go. I've had decent luck in Go, not nearly as much luck as I've had in Python, but yeah, it's definitely useful in doing a lot of boilerplate kind of stuff. Go has this feature, bug, whatever, rule, that you're not allowed to have variables you're not using. And AI is awful at that. It's terrible, terrible, terrible at generating code without having extraneous variables that then the compiler blows up on. It's almost every time I ask it to do anything in Go, and it's just, I don't understand why it's so hard. But anyway, actually, I know why it's so hard. It's because it has no long-term memory kind of thing. All right. Okay. So now he's talking about the craft of programming. I'm not one of these like artisan types, right? What's important to me is that the code is competent and that the code solves the problem that the code is supposed to solve. And the code doesn't create any new problems, right? And the competent and not creating any new problems are tied together pretty tightly. When AI generates bad code, when humans generate bad code, when people generate insecure code, that creates bugs that, as I've said over and over again, hurt everybody on the internet. Because anything that will make a machine become a platform that can get used to attack somebody else, then we're all a little bit less safe, which means right now we're not very safe at all. But I don't know. But the craft is not really a argument that I worry about that much. This one, however, the idea that mediocre code is fine is both true and not true, right? So I have a lot of code that I write, that I use on a fairly regular basis, that is mediocre or worse. That code is stuff that I use to automate things related to videos. So like I've got some code that marks up PDF files and chops them up and puts them on this tablet so that I can use them for videos. I haven't been working on that very long. It's really a bunch of really crappy stuff. That's fine. It will get better over time. Nobody can get hacked because of it. Nobody ever runs it but me. For that kind of stuff, AI is fine, right? That kind of stuff can be mediocre. Some of the stuff that I've got right now that I'm using is less than mediocre. It's pretty crappy, but it still saves me time over doing everything by hand, right? So I have a lot of stuff related to creating videos and, the way I get text onto the prompter and a bunch of stuff like that. That's just, stuff that saves me time, but it's crappy code, and sometimes it's buggy, and sometimes it doesn't work right, and sometimes it creates other problems, and I have to go fix them and that kind of thing. And that's no big deal, right? But those generally aren't the kinds of programs that I write professionally. The kinds of things that get done professionally generally means there's somebody that's not you. There's some customer, there's some sucker on the internet, unfortunately, who's potentially going to be hurt or at least inconvenienced if this thing doesn't do what it's supposed to do. You might lose their data. You might become a platform for somebody else to get hacked off of. Any kind of those situations, mediocre is not good enough, right? I'm not okay to say it's okay if the code's mediocre. One of the things that really bugs me is this right here. And this is not an unusual take, he does not think that tests are nearly as important as I do. To me, tests are more important than the actual code, because the tests allow me to experiment with the code and to not be on my game that day and to be tired. And it allows me to make mistakes and not stress about making mistakes, because I know that the tests are a safety net that will help me and will catch me, right? And programming live without a net on production stuff is terrifying. I've done it before. I don't like to do it, but sometimes you don't have a choice. The tests are vitally important to me. And the idea that, maximum effort on a unit test is a dumb idea just makes my blood boil. This terrifies me. The idea that he thinks that the worst code that the AI writes is better than the worst code that he writes. That's definitely not true of me. So I don't know. I'm not okay with that at all. Especially somebody that's been doing this since the 90s, that's the kind of thing that would be a giant red flag for me, like in an interview process, right? Somebody who said that in an interview, I would be very likely to say, I don't want to hire them. I don't like this either. So this idea that that AIs have a bigger bag of tricks than you do. Sure. Why is that a good thing, right? The idea that we want the code to be as fast as it can possibly run, and we want it to be as clever as it could possibly be, in my opinion, is a very bad idea. A very, very, very bad idea. There was a quote from I think it was Brian Kernel. I'll see if I'll find it and throw it up on the screen, that says something to the effect of, and I've talked about it before. Debugging is obviously harder than writing the code in the first place. And so if you write the code as clever as you can make it, then you're not going to be clever enough by definition to be able to debug it. If you're allowing the AI to use a bunch of algorithmic tricks that you don't understand, you've got zero chance of debugging it. And we've already talked about the fact that the AIs don't do a good job of debugging it. So this is all like, this is bad, right? Just do not have code in your code base that you do not understand. Do not have code in your code base that you can't debug. Do not let, and this goes for, other people on your team, do not let there be code that you depend on that you don't have an understanding of how it works to the point that you can start tracing it through in your head and debugging it. This is, I don't know. That just terrifies me. I'm with him on this one. I don't think that AGI is necessary in order to be able to use it. And in fact, I think that AGI is a detriment to using it now. Because right now, there are a lot of people who are trying not to use AI or wanting not to use AI because and I'm talking more in the business world than in the helping it to do my work as an individual contributor kind of thing. There are a lot of people who are not trying to make businesses that revolve around LLMs right now because they're expecting that next year or the year after that, a new LLM is going to come around and make whatever they're going to build today useless. And if we accept the fact that, if we can convince ourselves, and we turn out to be right, that we're not going to get AGI anytime soon, which is all of the evidence points to that at the moment, or at least all of the publicly available evidence. If there's evidence that AGI might be coming, then the AI companies have it and they're hiding it, which would not be in their best interest. So the impression I get is that they basically put out stuff and they have to lie to us about how good the stuff is. And a lot of times we find out that they told us that the code did a lot, or the AI did a lot better on the benchmark than what it actually did. So if they had something that actually really indicated that AGI was coming, I can't imagine they would not want to put that out there, but whatever. But yeah, in my mind, the sooner we stop worrying about AGI, the easier it's going to be for us to actually start getting real work done. So the job thing is a problem, right? There's useful stuff here, right? The idea that we're a field premised on taking other people's jobs away. This is actually very, very true, right? There have been a lot of jobs that I have automated out of existence because people used to do things by hand, and I was part of a project that automated all that kind of stuff, and those people didn't need to do that anymore. In most of those cases, as far as I remember, the people had other things that they could be doing now. But I've absolutely written code that took job functions away from people. It's certainly true that it's not fair if everybody else has to worry about computers automating their jobs and we don't. So I'm fine with that. The problem is where that's happening, right? So right now, from what I can see, the biggest group of folks that are being hurt or being not hired because of AI are the folks that are fresh out of school and the very junior people. And the problem with that is that if we have an entire generation of kids, I'm in my 50s, I can say that 20-year-olds are kids. If we have an entire generation, feel free to yell at me in the comments. If we have an entire generation of kids that don't ever get CS jobs, or a lot of them don't get CS jobs, then where are the people in mid-career that are going to be able to debug these things going to come from, right? And so the problem right now, as I see it, is not that that AIs are taking development jobs. I think in the long run, it's going to end up making more development jobs because we're going to have a lot of more debuggers for all this code that's getting written faster than we can actually debug it. The problem is that those job losses and those jobs that don't get created in the first place tend to disproportionately harm the potential future of the career. And I don't know what to do about it, but it scares me. So when it comes to code, I do not care about plagiarism at all. Full stop. There's copyright. If you steal somebody else's code that was proprietary, that's not fine. If you steal somebody else's code that was proprietary, that's theft. That's not cool. But the idea that AI was trained on publicly available code, and so therefore you're stealing from people that have publicly available code if you use AI, I don't. That argument doesn't hold any weight with me. I can see how there are people that are in the illustration world that are concerned about that. I try really hard to limit myself to what I see as my lane, which is basically how do AIs interact with code, and I don't know or study or pay enough attention to, and this is deliberate, to what's going on in other. I hear anecdotes about illustrators and writers and stuff, journalists, but I don't spend enough time actually looking at the economics and the job prospects and the unemployment numbers and all that kind of stuff for other careers that I don't really feel intelligent enough or qualified enough to speak on that. In the context of AI generating code, I'm not concerned about plagiarism. That's not a thing I care about. This whole thing, this bit, right, where you get up, you throw a bunch of stuff at your agent, you go get coffee, do whatever you're going to do, you get back a bunch of pull requests, you send some of them back, you purge some of them, that kind of stuff. I've said before, I don't think so. I'm not going to say that pull requests are a bad idea because it's better than nothing. But the idea that pull requests are any kind of actual increase in code quality is, in my experience, not true. I would say that code reviews are about net even. Because yes, there are stupid mistakes that people catch in code reviews that prevent them from going forward. But on the other hand, there's also a lot of time wasted on stupid pedantic arguments about what happens in code reviews. So on balance, I don't think that they're a big improvement. Potentially, there would be more stupid mistakes if people thought they would be able to push their code without having to go through code review. So maybe it's net a little bit better. But the idea that you can have 13 PRs come in and have 5 of them get merged in a day, that says to me that someone's not doing due diligence in actually reviewing the code. That is, again, a recipe, just like AI writing code. That's a recipe for bugs and security problems in my book. I understand the idea that someone's tired of hearing about AI. It's not going away. That's not going to help. So the idea that you're dumping the stochastic parrot argument against AI with the vibe coding argument against AI is like, those things are different, right? The stochastic parrot thing is not an argument about can AI help you get your day-to-day work done and take some of your tedium away. The stochastic parrot thing is about, can the AI up here do a thinking job of something that a human can barely do or can't do at all, right? The stochastic parrot basically says that all they can do is remix stuff that's already existed and they can't create new stuff on their own. They can't come up with novel things. I tend to mostly believe that theory, but that's not the same thing as vibe coding, right? Vibe coding is basically like throwing a bunch of stuff out there and just not caring if it works or not, and then being surprised when it blows up in your face. The idea that, I don't know, maybe he's trying to say that they're all the different arguments and these are 2 different schools of thought, 2 different kinds of arguments. Neither of them are going to survive for another year. I think the stochastic parrot stuff is going to be borne out. I think that's going to be confirmed. I think that that's what we're going to be looking at AIs as being a few years from now. But stochastic parrots are not useless, right? There's a lot of really good things you can do with autocomplete. There is no AI on the that I've ever touched that can't type faster than I can, and can't type faster than, I mean, even these people that spend all of this time trying to get their Vim stuff to the point they could type 120 words a minute with code, whatever. You're not going to be able to keep up with an AI. Just don't bother, right? That's not useful. But they can still be stochastic parrots and still be useful. which is the situation I think that we're in. Vibe coding, again, vibe coding is good for stuff you're only going to run yourself, stuff you're going to run once and get the output and use the output and throw away the code. I do vibe coding for that kind of stuff all the time. But for stuff that you're going to ship that people are going to be able to attack and try to hack, don't do that. That's a horrible idea. But this essay makes the same kind of issue that a lot of people do, which is basically, and honestly, it's not entirely his fault because the AI companies intentionally try to confuse us this way. The idea that an AI can be useful down here, and the idea that an AI can be as smart as a human or smarter than a human up here are two very different ideas, right? The fact that you have an argument that says that it's not going to be, would you say AI is not going to be as good as smart as a human? That's not necessarily saying that an AI can't regurgitate combinations of existing code faster than a human can, right? One of them is about actual reasoning and thinking. One of them is about being able to do new things that no one's ever done before. And the other one is about autocomplete. And saying that it's really good at doing autocomplete is great, but that doesn't mean that the argument that the thing is going to be, super intelligent in a few years holds any water at all. One thing that's hard, and I have this trouble when I talk about generative AI, is when you get this conflation between at the bottom level it's useful and at the top level it's not going to be as good as a human. So it's unfortunately the companies aren't doing us any favors by actually they're actively hurting us by trying to conflate those two on a fairly regular basis. All right, enough about this essay. Let me go to the next thing. This is the thing that really blows my mind. This is another video from Low Level TV. You should go watch this one. I'll have it linked in the description about this particular bug, combination of bugs. I'm not going to go into great detail about this, but it's a very interesting idea, and there's a lot to it. So again, I'm not going to go into a lot of detail, but let me talk through this. So here's what happened. We've got this engineer. We've got this issue where this security researcher found a remote zero day in the Linux kernel using O3. It's more complicated than that. Again, I'm not going to really get into the details of what the actual bugs were. Go watch Low Level's video for that. But here's basically what happened. So this researcher found a bug, a nasty bug in the Linux kernel. So then what he did, he took the code where he knew that a vulnerability existed, right? And then he started to ask the LLMs to look at the code where he knew there was a problem for the particular kind of bug that he knew was already in there, and then asked it what it thought and what bugs it could find, right? And so here's what happened. So he sits down and he finds that in 8 of the 100 runs, the O3 found the vulnerability. Another 66 runs, it didn't find a bug at all, right? And then 28 runs were false positives, right? So in 100 runs, it found 8% of the time it found the bug that he knew existed. 60% of the time it said there is no bug when there was a bug. And 28% of the time it said, oh, here's a bug, and that bug didn't exist, right? So these are not great odds. And if you are interested in the details of this, go after you watch the Low Levels video. He's actually uploaded the prompt that he used and the output that he got and all that kind of stuff, right? So before, when he was asking O3 to find the bug, he was giving it about 3,000 lines of code. So what he did is he took about 3,000 lines of code that were specifically associated with the bug that he knew was there. And then from there, he told the LLMs to look for the kind of vulnerability, the use after free vulnerability that he knew was already there. And then saw what output he got and how he got some good ones and he got some false positives. So then he said, okay, so I know that less than 10% of the time, but still sometimes it can find the bug that I know in the code that I gave it that I know was relevant to the code to where the bug was, right? So then he said, okay, So let me expand that, right? Let me pull up to 12,000 lines of code and let me give it all of the code that's the least bit relevant to this, right? So now effectively he's giving it a lot more context and saying, okay, I wonder if the LLM can find the bug the same bug in 4 times as much code. So it's got a lot more context. I'll give it that whole thing. So a bunch of stuff that I know isn't relevant to the particular bug that I want it to find. I'm going to give it a whole bunch more stuff, see how well it does, right? And this time it got it in 1 out of 100 runs instead of 8 out of 100 runs. So by quadrupling the code that it was having to look through, it managed to work an eighth as well. However, along the way, when he went through all of the things that looked like false positives, he actually found another bug, right? So there was one bug in this. He gave it the whole context. It found that one bug 1 out of 100 runs, but it also found another bug that this researcher had not found himself. That bug, there's no reason to believe that bug would have been found otherwise anytime soon. And what's worse, he had proposed a fix to the original bug that he found, right? And then he realized after he read the new bug that O3 had found that the fix that he had proposed wasn't good enough. And it was still vulnerable to the thing that was in a similar kind of situation to the second bug that O3 had found. So what we ended up with basically in this situation is so we started in a situation where there were 2 bugs in this particular chunk of code. The researcher found one. He wrote a fix for it that turned out that it didn't actually completely fix the problem. It just made it a lot better. If he had stopped there and not been interested in trying to experiment with the LLM and see what the LLM could do, we would have gone from 2 bad bugs in the kernel to still 2 bad bugs in the kernel, just one of them wouldn't be quite as bad as it was before. Because he spent some time playing with the LLMs, and I don't know how much time, but because he went through all of that effort and dug into all of the code, we actually have 2 bugs fixed now. And this is not a thing that you can just sweep under the rug, right? This is a thing, and these are the kinds of issues that computers in general and AI and LLM specifically are very good at because they don't get tired of things that are tedious, right? You can only stare at code so long before you can start seeing that there are potential problems. And race conditions in C and C++ code are hard, and especially on this particular one, the bug is it's got some code in kernel space and some code in user space that are interacting with each other. And they can be on different threads and things can get really complicated. And that's a really, really hard kind of situation to try to work through in your mind. And even if what you end up with is an AI that just generates different permutations of how it might go wrong, and then spend some time figuring out through those which of those are actually feasible, that's likely to find things, assuming there's something there to find, which is always the trick. Assuming there's something there to find, that's likely to find things better than you are by just scanning it manually. And this particular kind of race condition that this is a thing that's really hard to write automated fuzzy tests to find for various reasons. I guess the thing to understand about this, right? If nothing else that I've said today resonates with you at all, this is really an indication that it really is the case that programming is never going to be the same. These things are not going to go away. And as one of the essays said, even if LLMs stopped and didn't make any more progress today, it would still change programming as we know it. I think that's absolutely true. And it's not going to be possible. It's not going to be likely. I'm not going to say possible. it's going to be very unlikely for anyone to be able to be productive as a software engineer going forward without having an understanding of how to use these tools and skill in having to use these tools. This is not something you can try to ignore. This is not something you can wave away. And it's keeping up with this is hard, right? I used to complain a lot about all the JavaScript frameworks, how much of a pain in the ass it was to keep up with all of them. And okay, being realistic, I still complain about all the JavaScript frameworks. They drive me crazy. But trying to keep up with what's going on in JavaScript frameworks is nothing compared to what's going on in generative AI right now. It's just everything is moving so fast, and some of it is dead ends, and some of it's going to be really useful, and a lot of it you can't tell if it's going to be useful or not. And there's not really any way to. There's not a career safe way to opt out of that and say, okay, I'm just not going to pay any attention to that. That's putting your career at risk. We need to figure out how to make the best use of AI now in the situations where the code that we're shipping isn't mission critical, isn't on the internet, can't be hacked, and save our time and our mental effort for the stuff that's more important. And we need to get good at using AI to make ourselves more productive that way. The next thing that we need to do, and there is not an answer for this, and my guess is this is going to be a very valuable thing to learn how to do. It's going to be hard to do it, and I'm guessing that it's going to be something that's going to need to get done outside of LLMs. But figuring out how to sift through lots and lots of LLM output and lots of false positives, and figure out what is and what isn't worth escalating to a human, and what is and what isn't worth actually spending your time going through by hand. That's going to be a really, really important skill. I don't know that anybody knows how to do that right now. There are a lot of people that say that they do. There's a lot of writing LLMs to filter the output of other LLMs. I've not seen any evidence that actually is useful. Yes, it's going to filter down the stuff, but we have no reason to believe that it's filtering down the right stuff. So at the moment, it's going to generate more code than we can really read. And that's going to lead to a bunch of problems, and we're going to have to figure out how to do that. And if you're listening to this and you're a software developer, then hopefully you can be part of the conversation about how we go about figuring out how to take the output of these things and figure out how to make it useful. I don't know if I've told this story before on this channel. Or not on this channel, but on my channels. I probably have, but maybe not. But once upon a time, about 25 years ago or so, I was working at Sears, the company that used to have the big catalog thing, working at a big call center here doing IT for them. And we had this project, and we ended up shutting down the mainframe that we had up here in Round Rock, near where I live. And we shut down this mainframe. And there were two guys that worked for me who worked on the mainframe. And I got to sit down with them and say, your job's going away, right? We don't have any, that mainframe's getting turned off. We don't have any need to have it programmed anymore. There's only one of those mainframes left in Sears. It's up in Schaumburg, Illinois, which is where corporate. It's fully staffed. There's no job for you there. They had a package to go to try to get themselves up on some new technology. They got funds to be able to do an offsite training kind of thing. I don't know how that got resolved, but what I know is that made a big impression on me. And my biggest fear the last 25 years has been getting to the point where I get to sit down with somebody and have them say, the skills that you have just aren't useful anymore. And we don't have anything to do with you. And we wish you luck figuring out what you're going to do next. And now, to some extent, I'm trying to pass that information on. My guess is it's going to be harder in the next 35 years to stay relevant. Staying relevant is hard in this field. I'm not going to sugarcoat that. Things change a lot, and things have been changing faster. But having been in this business since 1989, I can tell you that if you want to have a long career in this field, you have to get comfortable figuring out the new thing and staying current. And if not, then the less current you are, the more risk there is of you waking up and realizing that there's nothing that you know how to do that anyone cares about anymore. I'm not here to sugarcoat things for you. This is an inflection point. And I expect that people that don't take time to learn how to be productive with generative AI are going to find their prospects diminishing over the next few years. And so I urge you to keep that in mind as you decide how to spend your time. I wish I could tell you it's all going to be okay. It's going to be exciting. If you're the kind of person that I am, if you're the kind of person that really loves technology, you're really passionate about it, despite the irritation and despite the bad code and despite the fact that people are in this, AI derangement syndrome, and treating it like it's much better than it is, and the damage that it's going to do from that, it's still an exciting time. And there's still a lot of things that I can do with it that I never would have expected to be able to do with it. On balance, I think this is going to be better for us, for developers in the long term. Short term is going to be rough, both for AI reasons and for the impact it's having on junior developers and just the current economic environment. Things aren't good in the job market now. I don't expect them to get better. I think they're going to get worse before they get better. I wish I could say that wasn't true, but I can't. I think it's going to be kind of bad. It's already kind of bad, but I think it's going to be good for us on the other side of it. I think it's going to be exciting. I think it's going to be really useful. So I guess I will leave you with that. I don't know if you're actually going to see this version. I don't know if you're going to be seeing me over there where I usually am talking to camera, but thanks for watching. Let's be careful out there.